over and over again, so I'll try and answer them. So the first one is, why do you sometimes need to add this dot in an import? Okay, and I guess the easiest way to explain this is to show you in case where the dot is important. So if you don't use the dot, then things start breaking. So I just delete this. So I have a little demo problem here that I just created that shows you why the dot is important. So here, what I have is I created a package demo. That package has an init file, right? And it has a module called sys.py. Okay? And let's look at what I've done in here. So sys.py simply defines a variable, and then the underscore init underscore. Maybe this is also something that I should say, is that the underscore init underscore that's a file that just by its existence defines that we're talking about a package. But when you're importing the package, then actually the code in the init file is executed, right? That's what Python does. It checks if there's an init file, and if there is one, then it's a package, and then it executes that the content of that file when you import that package. So okay, so initially what I wanted to do, right? So let's say I'm in Python 2. Python 2 didn't have this dot yet. So I'm in Python 2, so then I would write from sys import A and then print A. Okay, so nothing wrong with that. So let's try if this works. I go into my Python shell and I import demo. Okay, and so now what happens is that it complains. It says import error, cannot import name A from sys, unknown location. Okay, anyone got any idea what is going wrong here? Sorry? Well, it doesn't. Yeah, but sys is in my local. It's in my package folder, right? So I should find it, right? Yeah.
It's trying to import the normal sys package for Python.
Exactly. Exactly. So what's going on is that, and I guess this is also maybe what you meant, is that sys is a system-wide package that is available on any Python installation. So essentially, there's a name overloading here, right? So Python doesn't know if it's supposed to load in the global sys package or the sys module that I defined as part of my own package. So that's why, in order to and so the problem with this is, right, you might not, so here at sys, we know that exists system-wide, right? But just imagine you're developing your own package, and you use not sys here, but let's say you use core here. From core import A, right? So this might work on your system because you haven't installed another package that has core, right? But maybe on someone else's package, there is actually a global package that is called core, right? And so suddenly it becomes really not obvious when things work and when not. And so for this reason, in Python 3, when you define modules, you always have to use the so-called relative imports if you want to import modules within your own package. So by adding this dot, you're saying, I want to import, I'm expecting a sys module in my current folder. That's what the dot does. And in that module, import the variable A. Does that make sense? So let's just test this. So I import it again, and now it works, right? You can also see that it actually, when I import it, printed out 5. So you can see that it actually executes that stuff that is defined in the init file. So then I want to show you another thing. And this is this is a convention in Python that allows you to specify hidden variables or hidden functions and so on. This convention is if you have a variable that you want to hide from the user because maybe it's only used internally and you don't want him or her to play around with it, just start that variable or function with a double underscore. Okay, that's it. So just to demonstrate this to you, so I have two functions. One is called underscore underscore hello, and one is just normal hello. Okay, and so the underscore underscore hello is a hidden function. So, and I want to show you what the result is. If you open up in IPython, you import demo. Okay, and if I do demo, and now I use a double tab, sorry, demo.sys. This is the function that I'm interested in. And so now, if I do a double tap, it shows the variables that are available in this. And IPython tells me I have an A and I have a hello. But it does not list the underscore underscore hello, right? Because I defined it as hidden. So I can run this. But of course, it doesn't mean that this function doesn't exist. Because I can, in fact, if I start writing with a double colon and then hit tab, so now I can see all the hidden functions. So I explicitly asked IPython to show me all the hidden ones. And you can see that my hello function is indeed in there. And even though it's hidden, no one stops me from actually executing it, right? For that reason, it's just a convention. There's no strict hiding private functions concept in Python. It's only a convention. But it's a very useful convention if you have large projects and you know that you have internal functions that you don't want to expose to the user. Questions? Yeah?
What about single underscores? How are they
different? Single underscores also exist. It's another convention. And to be honest, I will have to look it up what the difference is. Or maybe you can look it up and tell us in 5 minutes. Would that be okay? Or you tell us at the end of the lecture. Okay, let's go to Sphinx. So, right. So Sphinx is a much more powerful tool than pydoc that you can use to create documentation pages for your Python projects. And it has a lot of flexibility, and I've shown you a project at the end of the last lecture. So essentially, you need to install it, and then the easiest way to get started is to go through a so-called Sphinx Quickstart. So by executing this command, it asks you a bunch of questions, and then it sets up essentially the documentation page for you. So I guess instead of just going through this, I just demo it for you. That might be more beneficial. So let's go to Monty Hall game. And I'm going to delete the stock folder for now. So I guess we can also delete this env name for now. Okay, so we have a lot of files here, but essentially the most important ones is that we still have the spin file and the Monty Hall game package, right? And so now we want to get a documentation using Sphinx. So I type in Sphinx Quickstart. And now it's going to ask me a bunch of questions. But I'm just essentially going to keep the defaults. I just type in a project name, author name, okay. Project release, let's say 1.0, project language. Okay. Oh, this is not what I wanted. Okay, let's try again. So please, oh no, messed it up. This is really not what I wanted. Why is it? Okay, this is the problem of live demoing. Things don't work. Separate.
Did you try running make?
Yeah, it's just it's creating it in my main folder, and I want it in the documentation. Okay, I tested this yesterday and it worked. So maybe I'm using a different Sphinx version. But I'm sorry. I'm just going to check out doc. I'm going to skip this. So normally, if things work, you run this Sphinx Quickstart, and it creates a doc folder that contains the core documentation. And then what you run is you run Sphinx API doc minus o doc. So it's telling you want, well, so the Sphinx Quickstart creates the core, and then the Sphinx API doc generates the documentation for a specific module. So in our case, we would run this command here for the Monty Hall game package, right? And so it would then automatically add all the documentation of that package inside to the documentation. So then we have this, let's see, so this is now the content. This is the content of the doc file. And essentially you have a conf.py, some configuration stuff. Then you have index.rst. If we have a quick look into that, it contains some, it just contains some text that I've added that describes, that introduces the game. So this will be rendered. You can see this is again this markdown style here, and this will be rendered much very nicely later on. You can see I have some installation, starting the game and indices and so on. Yes, and then lastly, there's a file called Makefile, and this is again a new concept that you haven't seen before, but Makefiles are almost like bash scripts, but they contain multiple tasks that you can execute. And the way, when you have a Makefile in a folder, you can type in make, and you can actually use a double tap, or you just press return, and then it tells you what are the different options that you can, what are the different tasks that this Makefile knows. And so in this case, you can see if I type in make HTML, it creates, or it makes HTML files. You can also do, let's see, LaTeX PDF, then it would generate a PDF version of the documentation and so on. But the point here is that if I'm in my doc file, I can now type in make doc, make HTML. Okay, then it runs loads of stuff. There's some warnings that just some warnings that I'm just ignoring for now. And it tells me that the HTML pages have been built in this subfolder. So let's open this. I go into build HTML, and I press return. I guess I need the index file. And there we go. So here we have our Monty Hall game documentation. And this is the text that this index.rst is essentially the text that you see here, that I've copied from Wikipedia. Here you have my installation instructions, some instructions on how to start the game. And down here, you also have an index of the modules that you can click on. And you can see there's two packages defined. One of them is our Monty Hall game. And here's now our documentation, the doc strings that we've created. For some reason, the code here isn't rendered quite nicely. But here you see, this is what I talked about when I said that the variables and the return values need this special colon syntax, right? And this is the reason, because then it renders it nicely. And also you can click on source, and you see the associated source code for that function or class. Okay, does it make sense? Yeah?
Does it only work with Python?
Sphinx only works with Python, but you have similar concepts for many other programming languages. Yeah. So in general, many of the tools that I'm showing you today, they might be Python specific, but the ideas, they are always often applicable to if you work with C++ or Ruby or whatever, right? Many of the concepts carry over. Okay, so now these are our new files. So now we have the doc folder, and we have these auto-generated files from Sphinx. And some of them I had to edit, right, to make it more specific. Okay, but now comes the really cool thing, because now programmers are really, really lazy, right? And we don't want to do repetitive tasks. And so specifically, when I update my documentation, so first of all, I want to have my documentation online, and I want to have my documentation always be up to date with the source code. So the way you can achieve that is that there's a service called Readthedocs. It's a web page that essentially you point it to your GitHub repository, and it checks if there's a doc string inside, and it checks if there's a doc folder inside. So and if there is, then it automatically compiles it to get the online documentation, makes it available online. But it also listens to your GitHub repository, and whenever you push to the GitHub repo, it updates the documentation. Which means that you set this up once, and then you don't need to worry about documentation anymore. You just code up, you make changes in your code, you push to your repo, and the documentation is automatically updated. So I just want to, let's see if this works. So I log in here. You can see I already have some projects. I click on Import Project, go to my repository. We need to find the Monty Hall game in here. It's probably on the next page. Monty Hall game. Oh, I didn't want to go to that page. I wanted to import it. No, let's try again. Okay. Okay, I want to add it. I just keep this default settings. And then I just click Build Version, just because I don't want to push now, so I just wanted to build it for me. And so now now you can see that it downloads, it checks out the master version, then it does some cleaning, then it reads the documentation configuration file. It takes a minute. It actually also builds, you can see it also builds the LaTeX version, so it will also create a PDF version. And then, yeah, it's done. So now I can go to V's documentation. And so now this is now available online with exactly the same documentation that I've just shown you before, plus some marketing. Okay, but the point here is that I've set it up once, right? And now if I push to my repo again and make changes in documentation, then this will be automatically reflected also online, and I don't need to worry about it anymore.
I guess it only works with public repos or also with...
This works for free for public repos, but I guess you have to pay for, yeah. But actually, yeah, so I should make a disclaimer. I'm not associated with any of the services that I'm talking about today, and they're all for free for open source projects. These are just the ones that I use because they're really useful. But I think actually Readthedocs is an open source project. So you should be able to just, if you wanted to, you can host it yourself on your own server. Okay, so now let's move on. Next step is that, of course, we should be able to handle errors. So that you already know how to do. It's these exception methods. We have to handle exceptions. So I just show to you how I did it, how I solved this. So I decided that I wanted to have, I decided that I wanted to have, no, this is not. Let's see, on the whole game. I defined my own exception class, just so that the error messages are a bit nicer. So I added this invalid game input exception, because that's the most common, that's the only error that I'm really handling. So if the user types in the wrong door, for instance, and I just have a, yeah, it's very basic. I did it more because we can. And then in the command line interface, sorry, in the class module, so here, for instance, if for the user exposed functions, like the selector one, I check if the inputs are correct, and in that case, I raise an invalid game input exception, right? And so that essentially that's the only logic that I changed, because I wanted to raise, in this case, I wanted to raise the error as early as possible. As soon as the user types in something invalid, the program will stop. Yeah, but I don't want to say too much about it, because you already know this. The next thing is about adding tests. So that you also know. So I just want to show you how it works. I used how I've done it. I used PyTest. And again, for larger projects, it's good convention to move all the tests into its own subfolder. So I created a new subfolder called tests. Inside there, I have test module.py, or it should probably be test game Monty Hall package or something.py. But I just want to show you something that is maybe a bit useful. So this is about the naming convention of these tests. So the name of the test in principle don't matter, right? PyTest only requires that the function name start with test. But it's always good to use a descriptive name for your tests. And the reason is that if a test fails, you should be able to guess just from the name of the guess what is going wrong, right? So just so that you, in essence, that you save time later on, that you don't need to dig through the code where exactly it failed and where not. So in this case, right, if you here, all I'm doing is test that, so I actually use entire sentences here to make it descriptive. Test that game wins or loses, right? That there's no strange other cases that can happen. Or here, test that selecting invalid door raises correct exception, right? So it should be hopefully quite self-descriptive. So what I do is I create a new game. I try to select door number 4, which doesn't exist, right? So I should never be able to get to the next line. So that's why I add an assert false. And I read that into try statement, and I actually expect in this case an invalid game input. Right? So this test will actually only pass if I get an exception. And then here for the statistics, it's a bit difficult to test the statistics, but at least I expect that it returns a string, right? That I can actually call the statistics function and it returns a string. It's the best thing that I could come up with. I'm sure one can do this better. Okay, so this is what a testing setup might look like. And of course then, oops. Yeah.
What's the assert function in the first? The assert statement in the first function have any effect?
Oh, you mean this one?
No, the one above. Yeah.
Yeah, good question.
Do you need it for the test to run on top or something?
No, you don't. And actually, yeah, I agree. This is probably not such a good test. What I meant to do here is maybe, but don't. Okay, I'm not saying that this is a good test. I agree that this may be. My point was maybe that what I wanted to test is that open door returns a Boolean rather than integer or a string or something. Right? That's what I'm trying to test here. So I guess this is a better formulation than what I had initially. Okay, but the point here is that now we have a bunch of tests, and we can run them, right? We know how to run them. Python -m pytest tests. It runs them, and they all pass, which is great. But again, right, programmers are lazy. So every time you make code changes, you will have to run these tests, which is boring. So for this reason, just like we automated documentation, we're going to automate testing. Okay? And the way you automate testing is, again, we're relying on a third-party service. In this case, it's called Travis. Yeah, this is the quick way how you do it. It's not so exciting. You go to this web page and sign up and click on GitHub and accept. But essentially, you select the repositories that you want to have tested automatically. Maybe I'll just show you what the, oops, oh no. Lost it. Okay, so the most important thing, so once you went through the setup procedure, and then if you go to the Travis website, you have your repository showing up here, right? This is what I've just told Travis, please track this repository, my Monty Hall game. So now I can click on this, and in this case, I've already set it up, here you can see what the current status is of this project. But in order for this to get to work, there's one important thing that you need to set up, and that's another file that you need to add. And that file is called travis.yml. So the Travis service will look for this file, and then will follow the instruction that you have in that file. So I just want to go you roughly through the syntax that you have an idea what's going on. So first, you can see it's kind of it's a descriptive file. So first we say which language Travis works on many programming languages. Our project is a Python language, what I specify here. Then you specify the different Python versions on which you want to test your program, right? So maybe your project maybe you want to have support on both Python 2, Python 3.6, Python 3.7, right? And so then you list them all up here, and Travis will automatically test your project against all these Python versions, right? So now you can already see the advantage over doing it locally versus doing it on Travis, right? Because you would have a lot of virtual environment to do all these tests. Okay, then you have this before install thing. So this is here you specify the different commands that you want to have executed before the tests start. In this case, I just print out the Python version so that this is just for my own reference. Then I want to upgrade pip, just so I have the newest version. I also want to upgrade pytest. And then I install all here's my -r requirements.txt, right? And so the trick here is that if I ever need to have a new dependency on my project, I just need to add it to requirements.txt, and then I don't need to change this file anymore because Travis will automatically also install that dependency. Then there's the install. This will be executed before install. So here I just install the package itself, the Monty Hall package. And then script, this is being executed once the installation is finished, and I just execute PyTest, which then hopefully runs all the tests. Okay? And so now, whenever you push, Travis will listen to your repository, and it will look for the travis.yml file, and if it finds it, it will run the script. In our case, it's PyTest. And you can see this is what happened here. It ran 2 tests, one in Python 3.6 and one in Python 3.7. And I can click on it. So it actually tells me that it passed. It takes a little bit of time here. Okay, and here you can see the console output that we got when this test ran. So in this case, we get exactly what we've seen on our terminal, and so all tests pass. But of course, the more interesting case, so to speak, is if things start failing, right? Because then in here you see the error messages, and you can start having a guess on what went wrong. Yeah?
Shouldn't you do the test before you commit and push to your?
Oh, you absolutely should. Yeah. So the question is, shouldn't you run the tests before you push? And the answer is yes. But again, on your own system, you really test only one environment, while Travis is kind of the more thorough testing, right? Here you test different versions. Yeah. But I fully agree. So in principle, you should always run on your own terminal first and then on Travis. Yeah. This is really important for if you work on, if many people are involved, right? You want to, essentially you want to make sure that Travis is always green. Whatever you use as a repo should always pass. But this is, so, right, I mean, you say that you should always test before you push, but maybe there's someone in your team who doesn't do that. And then you can blame people, right? You can see, okay, on your commit, Travis started failing, so please go ahead and fix it. Okay, any other questions? So now our current directory structure, so you can see we're getting more and more files now. Let's just have a quick overview again. So our package is now the following. We have the Monty Hall game main folder. Then we have the README, the requirements.txt. We have the setup.py file. Then we have the actual source code, Monty Hall game. Then we have the scripts. We should also have the templates, should be a part of the main. Now we have the documentation, which is new. We also have the tests folder, which contains the tests. And then we have the Travis folder. And then we have also git ignore file. Did I explain git ignore files before? Yeah. So that's also something that you should have for any larger project, where you simply list files that you want to have ignored in your in your repository. So now comes the stage where we actually want to deploy our project. And I show you 2 deployments if you have enough time. So first one is a web deployment for web applications. And again, to do that, I use a service called Heroku, because it allows for free deployments of open source projects. This is again the guideline how you do it. The most important part is that you add a procfile.txt to your repository, where essentially you specify which command should be executed once it's uploaded. In this case, Unicorn is a web server, but you could, in principle, just also, in my version that I'm showing you in a second, I'd actually just type in play Monty Hall _ web.py. So I execute this script that we've written up. Okay, and so then the way you do this, the way you deploy this later on is that you need to first log in, you need to provide your credentials, then you need to extend the Git. Not so important, but I just want to show you how this, once everything is set up, how you do actually deployment. So normally, right, you do git push origin master, and here the origin stands for GitHub. Right, this is always the default. Now, after you follow this installation instructions, you can also do git push Heroku master, and that means that you're pushing the master branch to Heroku, which is this web server. In this case, it says everything up to date. So I'm just going to make a tiny change. Okay. Git push Heroku master. And okay, so I'm pushing to this web server, and now it will, you can see it says, okay, I've detected a Python app. It installs the necessary requirements. It does some compressing. Okay, now it's launching. And now, let's see if this works. If you go to this web page here, okay, so there's our magic game, and it works. So now finally we're at the stage where we stopped last time, that we can actually run some statistics. So do you want to get out your mobile phones again? And let's have a go. So hopefully we don't break the server now. So you should be able to go to montyhallgame.herokuapp.com. Does it work? Yes. Oh, we're getting some statistics here. Okay, you're very fast at playing. Okay, let's see what we get here. I should have probably worked out what the percentage is. But now we've got roughly, okay, so if you look at this, so you remember there was these two strategies, right? Either you stick to the door that you had originally chosen, or you change the door after the TV moderator opened the door. So these two lines represent these two strategies. The first line is when you change the door, and in how many cases have you won? So in this case, it was 56 out of 97. So roughly 60% chance of winning. And then if you stick to the original door, so you do not change, then roughly you have a 30% chance of winning. Okay? So you can think about it why this is. But I can tell you that we are quite close to the real values. So if you change your mind, then you should actually have a 66% chance of winning. And if you stick to the original door, then you should have a 33% chance of winning. So it's an exercise for you to figure out why that is the case. Okay, so I have 4 more minutes, and I just want to show you the last deployment method. So if you're not talking about a web app, but a Python library, then Python libraries are often installed using this pip install and then the library name, right? So wouldn't it be nice if we could do the same thing for our Monty Hall game? So if we could just do pip install Monty Hall game. And the answer is yes, you can do that. So pip is the official Python packaging manager. And there's this web page called PyPi, where you can register your own project to make it available to pip. Okay, so I've written down the steps down here. It's really just a two-step procedure. You first create a so-called sdist. You type in Python setup.py sdist, and then use the twine command to upload your distribution to PyPi. And once you've done that, you can tell your users to simply type in this. So I've done this already, so you can look at what this result looks like. You can see there's not much description here. And I'm on version 0.01, so it's a bit boring, right? But you can see how it works in principle. And you can also see that this should actually now work on our systems. So we can see, if I copy this. Yeah, so in our case, it actually says it's already, we've already installed the Monty Hall game. Okay, so what have we changed? Yeah, this is essentially the same thing as before. We only added this procfile.txt for the Heroku application. So I just wanted to summary, because there's a lot of concepts today that I've discussed, so I thought I'd just go through them again and structure them a little bit. So I've shown you topics around installation. So that was virtual environments, Python virtual environments, and requirements.txt. Creating a package and adding a setup.py, adding a README file. I've at least mentioned the existence of Makefiles. So hopefully when you see Makefile, at least you know what you have to do. Then we have talked about testing. So of course, PyTest is essential here, but also this idea of continuous integration, that tests automatically executed when you push to your repository. Then documentation. I've shown you Sphinx and pydoc, and again, automation through, in this case, Readthedocs. And then deployment/publishing. This I actually have not talked about. Git also allows you to set tags on specific commits that represent versions. So your Git history can have commits that represent specific versions of your code. So this is the short version of it. Then I've shown you deployment of Python libraries using this PyPi manager. I've shown you deployment of web application with the Heroku. And then I've mentioned at least also that there's something, if you want to be out, not just Python, but actually more general deployment, you can use concepts like Docker or maybe Conda virtual environments and things like that. Okay, so this was quite a trip through various different things, but I hope it was useful. Are there any questions? No? So I can just mention the new assignment will be on, we're going to use, not so much the concepts today, but we're going to use pandas, we're going to use Flask, and we're going to use scikit-learn, which I'm going to talk about next time. So I think it'll be fun. See you next week.